Question 2. We're given a fourth degree polynomial, and now we're told that f of 1 minus I is a zero of that polynomial, because f of 1 minus I equals 0. And we need to write f of x as a product of two trinomials. So this is useful because it gives me one part of one trinomial. Now there are no unreal numbers there, no irrational numbers there. Therefore, it means that if 1 minus I is a zero of that polynomial, then 1 plus I must also be a zero. Complex conjugates for an equation with real coefficients. Now let's use a very useful shortcut, which is that x squared minus sum of roots times x plus the product of roots equals 0. Because if we take those roots and add them together, the i's cancel out. And if I take those roots and multiply together, we have a difference of squares. So therefore we have x squared minus 2x plus and our difference of squares. Minus r squared, well, r squared is minus 1, so minus r squared is plus 1. So we have 1 plus 1, giving us x squared minus 2x plus 2. You can take the longer way around, which means putting each of these zeros into brackets as factors with the x, and an x minus each of them. Now we're going to rearrange the brackets and put x and minus 1 together in the brackets. And we'll have a plus r from minus minus and a minus r from minus plus. And we now have a difference of squares. X minus 1 all squared minus r squared. Of course, that's x squared minus 2x plus 1. And that there, as in there, is plus 1. And it simplifies to the same answer, just with a couple more steps. So now we know one of the trinomials that multiply to give us that polynomial. So now we're going to do it by inspection now, by far the easiest way. You can divide that into that if you want. You can divide the trinomial into the polynomial to get the other one. But this is far quicker. We say that x squared minus 2x plus 2 must multiply another trinomial to give us that polynomial. Well, that must be x squared to give us the x to the 4, and that must be 2 to give us the 4 when they multiply out. The only one that's tricky is the mx, because that combines each of these terms within is a result of a combination of at least two products. So now what I'm going to do is I'm going to look at the x cubed term, minus 3x cubed, and say, how do we get the minus 3x cubed? Well, x squared times mx and minus 2x times x squared gives us our minus 3x cubed. There it is there. And that means m minus 2 is minus 3, give you m is minus 1. So we can now put that back into that equation. And there is our product of two trinomials. Part 2 of this question. Hence solve for f of x equals 0 in C. Well, there's a reminder of what we had before. We don't have to worry about that. We already know the roots of that. And we're going to factorize that one. So there we are. We're going to, in fact, we're not going to factorize. It's this one. Sorry, we know that one. We're going to use, we can't factorize it. We're going to have to use quadratic formula. So therefore, this gives us 1 plus or minus 2 root 2i over 2. And the other one, we already know 1 minus I, 1 plus I. Sorry, that should read 1 plus I. There, magic, fixed. Let's go on to the next one now. M over 2 minus 4i equals 1/3 plus ni. Calculate the values of m and n. The thing we really need to notice here is we have a single term there, and there we have a plus bi there. So what we need to do is try to write the left-hand side in this form. Now, the only way to get rid of the I underneath is to use a difference of squares, 2 plus 4i. So I'm going to take m minus 2 m over 2 minus 4i, and I'm going to multiply by 2 plus 4i over 2 plus 4i. Not changing it. This is still 1, so it's no value change. So on the bottom line, we're going to end up with a difference of squares. So therefore, m times the top line, 2m plus 4mi, and on the bottom, we're going to have 4 plus 16, 20. Therefore, 2m over 20 must equal the the 1/3. 2m over 20, the term without the I, must equal the 1/3. And 4mi over 20 must equal the ni. So we have 2m over 20 equals 1/3, and 4m over 20 equals n. So m is 10 over 3, n is 2/3.